Hello, I'm Greg Allison, Alabama State Director of the EMP Task Force on National and Homeland Security, organization founded by the late, great Dr. Peter Vincent Pry. My friends, I'm going to show you in this presentation why the Chinese balloons are a real threat as an EMP platform. How as an EMP platform, they pose asymmetric warfare threats like the likes of which we have not seen or hardly many people in this country thought about. But I guarantee you the Chinese have a large hidden military branch. It's just like their rocket branch of their military for ballooning. So they have a lot of people in there and they've done a lot of thinking. And the things I'm about to show you is available in open literature, a lot of this stuff. But I'm going to show you the different twists, and you're going to be shocked at how easy it is to launch EMP platforms from balloons, how easy it is to hit the United States with these, how it can be done from offshore and still take out our coastal facilities, how this can be done and be very difficult to detect, and contrary to a lot of blather out there. And I'm also going to show you how it's very hard to take these balloons down, unlike the spy balloon that flew, because this will fly to different altitude above the range of the AIM-9 from any fighter jet. So guys, buckle your belts, because this is going to be an interesting proposition here. So here comes the presentation. I am about to pull up the screen. There we are, guys. So we're going to rock through here. A lot of charts and just a little time. Okay, the EMP balloon could debilitate communications, data, and electrical power networks over large regions of the United States without coming into our airspace. And mind you, the power grid is our Achilles heel. Without the power grid, you don't have the data, the communications, the banking. You can't even pump fuel to run trucks. The supply chain is not existent because it's all computerized these days. So our whole country begins to fall apart. Now, to get a really good strong EMP, now you can get EMP at any altitude, but the strong ones, you need to be at 30 kilometers or higher. So one of the things, and one of the reasons I tell you the Chinese are acutely aware of this, they designed that spy balloon to have the capability to reach 30 kilometers with 1 metric ton. They don't need that much weight to do this kind of mission, my friends, contrary to a lot of beliefs. But they could put a lot of power systems on there, have synthetic side aperture radars and stuff like that. Yeah. All right. So the RF hemp altitude for a balloon at 30 kilometers, or the range, excuse me, the radius at which the EMP could reach from the center is 442 miles. That means you'd have a total diameter of the circle it could take out at 884 miles, my friends. And so you could be well offshore and detonate this. This is the scary thing. And I'm going to show you some other stuff on this. So yeah, high altitude balloons can easily carry payloads of 4 tons to well over, how about 120,000 feet instead of 30 kilometers? You know, let's go for 37 kilometers and higher. So it's easily done, my friends. And in fact, that kind of stuff is done, and it's done on a regular basis. So just we haven't had an EMP attack this way yet, but this is what you got to worry about. These are large enough to carry multiple EMP weapons on a single balloon, or you can launch a swarm of these balloons and overcome our defense systems, which aren't going to be able to reach them in the first place. And you could even carry multiple rockets with EMP weapons on them, on these balloons. I'm talking like a 6-pack, kind of like a multiple launch rocket system launcher, you know, but they'd be rocketing. It don't have to be as big to reach as far, believe me or not. Guys, here's what we're talking about. This is little circles that reflect the EMP range of what you could reach from a balloon. And this is set at the 30-kilometer altitude. This is the 30 kilometer. I would actually go for higher if I were designing this mission. I would have a little more range than this. I would go for 120,000 feet. So check this out. You could essentially launch balloons from outside our air defensive identification zones and get and detonate them still well over sea, way out to sea. This is basically the radius, the center. You can be way out to sea. Now this one's over land, but it's over Canada, so it's still not within the United States. Although the United States does patrol in Canada, we know from when we have taken down that little plastic party balloon, that little Mar-a-Lago party balloon with a picosat over the Yukon territory with an AIM-9 missile. Ha ha ha. Anyway, so if you put a couple of boats out here and a couple of boats out here and a couple of boats in that, say 3 boats, no, 6 total, and if they only launch 1 balloon each, this is what you could see attacking our shores all at once. And if you attack just New York, you could take down the whole northeastern power grid, by the way. but the EMP would do critical permanent damage to those high-powered transformers, just like some of the solar storms has done. Some people tell, I'll grade their heart. No, you know what? Solar storms still damage these things, including that 1989 Quebec hydro event, which took out Quebec, and also one in Salem, Massachusetts, and it took out a major long-range power transformer. And there have been since then, some taken out in South Africa. So we got more to cover here, guys. And we're talking about permanent damage. We'll talk about that in a minute. This is what you could reach, though. Look, all our coastal facilities, most of our military facilities, especially deployable troops like our special forces, Green Berets, Fort Bragg. We got our submarine bases down here and here. We got naval bases, San Diego. We've got all kind of military bases for our rapid deployment troops, Navy, Army, and we might get somewhere here to get some of the Air Force assets, especially strategic missiles. These are easily within range of balloons. These balloons are cheap. As you should know, that 9 out of 10 Americans could die from starvation, societal collapse within a year of the grid going down. This was reported by the EMP Congressional Commission, guys. So you can no longer pump fuel or water, ATMs, elevators, air conditioning, no prescription drugs. Your food won't be delivered to stores. Your bank, credit cards, all gone. So just imagine what life in the big cities would be like without power. And I've done a video on my Green Greg's channel talking about this, talking about how to survive an EMP. So just to show you, the Chinese are already getting up on this. The balloon we had come over America was a what we call a super pressure balloon. Super pressure balloon is one that is fully inflated and they pick an altitude for it to fly at, and it can fly for months. It's a more expensive, more complex balloon system. The balloon envelope is heavier. That's why it only take up 1 ton instead of 4 tons, but it can fly for months and it can set the altitudes. They've set it to be able to fly much higher than when it came over the United States. I was showing here why the one that came over the United States was set to fly at a lower altitude so it could loiter longer. I'm going to show you the wind profiles in a minute. But you see this test here? This is a zero pressure balloon. This isn't the same kind of balloon. This kind of balloon can easily reach 120,000 feet, even higher than your 30 kilometers. And the Chinese are already using these and testing these. And guess what this little package is here? This is listen, they've tested glide vehicles. They have tested balloon swarms. I'm going to show you these things, guys. At the end of this video, I'll show you. I got a surprise for you at the end of the video. See this? That is what's hanging on here. This is this. Those are like mini, it should say DF-17 hypersonic missiles. I got a typo here. It should be the mini DF-17s. They look a lot like DF-17s, hypersonic missiles. These are glide vehicles, and they got 3 different designs they were testing here a few years ago. So you can maximize cross range with either a surveillance system or a weapon. You could put an EMP device in this, guys, and get much further inshore than you would with just a balloon detonated where it is. This is this, so you could go cross range, go upwind if you happen to be launching downwind from the shore, and you can, there's a lot of stuff you can do with this, guys. That's the scary thing. All right, this is pictures of these packages where they were closer to the ground, being serviced. These are what the glide vehicles look like. You see, guys, and these could be rocket propelled to give them extra cross range. And I know something about that because I have built these kind of things, guys. The things I'm talking about here, I understand quite well because I have launched rockets and balloons at sea and out of the Gulf of Mexico. And that's the kind of stuff I'm about to show you guys. We got 3 main electric grids in the United States. Of course, you launch them on one coast. The further you can get those inland, the more damage you can do to all 3 grids. You can actually get the center of the United States practically if you got the right kind of rocket and you're launching a hemp device with a balloon on it. You could put some in the Gulf, put something on the West Coast, the East Coast. You can take all this out, guys, from balloons. And it's cheap. And it may be hard to, and it's going to be harder to detect than you think. Now, the Chinese have a couple options. They can launch a balloon swarm from China, in which case they would use the super pressure balloons. There's some risk that you'll see them coming over, but what have we done so far about it? We go, it's just another spy balloon. Well, it might be they suddenly launch a swarm of them. This is their facility in Hainan Island in southeastern China. This is a balloon facility that can launch balloon after balloon after balloon. They could do thousands of these from the deserts in China. and launch a whole swarm at us, or they can launch from ships. It's easier to launch a balloon from a ship than as a facility like this. A facility like this has a crane that moves as it's launching the balloon, as it's doing the final release, so that the wind don't tear the balloon up. It also lays the balloon out in the vector that the wind is blowing in. That's why you got a big circle here, so it can launch in any wind direction. When you're going from a ship, you go at the same speed and direction as the wind. You don't need any of this stuff. It's easier to launch the biggest balloons ever from a ship than it is from a platform like this. But they have a land platform set up, and they have a lot of radomes. I don't know why they got all that. Our facility here in the United States, facilities that launch balloons don't have all this stuff. So that is definitely a more bigger system. This is a function of EMP coverage as a function of altitude. This is, again, that circle you get at 30 kilometers. This is a circle you get at 100 kilometers, which was the altitude for one of my rockets I developed to launch from a balloon. This is about, like orbit, 400 kilometers. 400 kilometers, you can get 480 kilometers if you want to set it off from a satellite or an ICBM. Look, you cover just about the entire continental United States with this. If you take it out over northern Kansas, maybe southern Nebraska, Omaha, somewhere in that area, you could take out including most of Mexico, Canada. Yeah, the EMP from this would be devastating. Even at this outer edge, the field strength is still arguably strong enough to take out a lot of so-called hardened military facilities. But if you could take that same device and concentrate the entire EMP over a smaller area, I would think you're going to get a lot stronger field. So if you combine these techniques and hit the coastal areas with these, and then have one over the United States, wow, you could really do a lot of damage. This is the RF formula this is the formula that radio men use for RF range. This is basically how far you can get your RF to the horizon. And it's pretty close to what some of the analysts have come up to with the typical EMP range calculations. The ranges are practically identical because it's mostly still governed by the curvature of the Earth. And so what you can do is you can plug this formula here, and basically at 120,000 feet, this is the altitude I would select for an EMP mission. Your radius is 488 miles. That's the radius from the center of burst. That's how far inland you could reach. I mean, if I went straight up off the west coast of the ADIZ to a place where it's the biggest, 400 miles, you still get 88 miles inland, but you're going to be picked up by the wind, probably taken inland, or you may have some other means on board that rocket to take that thing right over the city. So there you are, guys. I'll show you that. So yeah, your zero pressure balloons are good for 120,000 feet. So your 30 kilometers is 18.64 miles. That's your 30 kilometer. At 100,000 feet, you're basically at 20 miles. So that's the difference, guys. So your 30 kilometer is real close to the 20-mile range here. That's a little bit under 20 miles, 5,280 feet per mile. All right, guys, just want you to see that. So this is the Starfish Prime explosion that took place 9 July 1962. And this was over the Johnson Atoll, launched from a Redstone rocket developed at the Redstone Arsenal, which is just south of me here presently, where I've worked for years. So guys, this is what a nuclear explosion at altitude looks like. This is an area you could go. If you did one of these, that Chinese so-called spy balloon flew right over this kind of area. If it had been an EMP balloon, it could have taken out all of our missile fields with one fell swoop. You see that? They're all within the scope range of one. And if you get the higher balloons, yeah, your range is even bigger. Like if you go to 120,000 feet. But we're sticking with that circle size for the purposes of this discussion for that altitude. I will show you what a raccoon like I built can do too. Now, this is one of my ship-launched balloon rockets. This is the Halo SL2 Skylaunch 2 Raccoon mission. Raccoon's a rocket launch from a balloon. And this shows a freestanding inflation. You don't do that on the ground because the wind would rip this all to pieces. It'd get blown over and ripped. But I'm traveling with the wind off of the NASA Pearl River barge on the 20th of June, 1998. So this lacked 16 days, been 25 years ago, the day I'm talking to you right now. And I'm sure I'm probably somewhere in this picture, if I'm not the one taking it. There we are. This is our SL2 rocket. That's a pretty good sized rocket, right? It was to hang off the edge of the balloon. With Steve Mistakis, who we just had a life celebration funeral for yesterday, unfortunately, and Al right in the picture. So this was 20 June 1998, Gulf of Mexico. Now again, balloon targets available from outside U.S. airspace. So just think, this is showing you what you can do from a ship. It's easy to launch a balloon from a ship. So if you launch from these ships, these are the areas you could easily hit. This would be still outside the airspace though, but it would be over Canada. But you could get this balloon too. We've already seen a balloon just over there without any contest. So who knows what they would pull. This is kind of what it looks like mission profile wise. I'm just going to get more exciting here in a minute, guys. So you rise to 130,000 feet. In fact, this was taken from another presentation I had. I kind of included, I tried to change the graphics a little bit, but we had a project I was working on. I was planning to go to 130,000 feet with a drop vehicle from a balloon. So I modified that. That's where the 130 goes from. Yeah, you can get 130,000 feet with balloons, guys. It's not unheard of. All right, here's your winds at altitude. So what you need to bear in mind here is that you get your jet stream down here. This is where your jets get pushed around by the air. Then you get up here where the winds die down at higher altitudes. And then you come back up to the altitudes I'd be launching at where the winds really pick up again. And that's an advantage for a zero pressure balloon to get over target faster. But this is basically where the Chinese spy balloon was flying. It was flying in this realm right here. Why? Because the wind speeds are so much slower. Because the wind speeds are slower, it can loiter over a target longer. You know, satellites only got, it just zips right overhead. You know, they have almost no loiter time. Well, these guys are lower. They got more instruments. They can use that side aperture radar because they had like 10 kW power on that balloon with solar power. So they had the ability to run the radar to be able to see to the side, to be able to see things you can't see looking directly down from a satellite. Plus, it could pick up cell phone and other critical electronic communications they can't get with a satellite. So they had interesting capabilities with that balloon. I've heard recently that one of the things we've come to believe is they were actually, in addition to our defense assets, targeting our power grid substations, doing some more intel on them. A lot of that can be done from just regular satellite photographs, though, even Google Earth. So this goes over your wind profiles. During the summer months, the winds turn around. They go at the altitude, the balloon altitude, they go from east to west. So if you want to launch from the Atlantic side, that'd be the time to do that. By the way, the Chinese have a major shipping industry going into Port Charleston. So they have a lot of cargo ships on the East Coast in addition to the West Coast. So they got plenty of platforms in which to do these kind of launches. Now there's a turnaround time in late September and late May in which the stratospheric winds die down. The balloon would go straight up. It might be the opportune time to launch from both coasts, and this is about the time that would be opportune for moving on Taiwan, because the sea states in Taiwan are also calm at that point in time. So this might be a coincidental time of vulnerability when they could take out all our coast without the need for any rocket assist and take out Taiwan too, all at the same time. So I'd be very suspicious in late September. So hang on to your hats, guys. That might be a time that they would make a move. So making more on that. So by floating down around 65,000 feet, you can steer back and forth. Now that's the Chinese spy balloon. Was that in that 50 to 60,000 foot range? That's the spy balloon itself right there. That's showing they got, you know, quite a bit of power. It's thought that they had 10 kW power. They had some kind of propulsion in here. They've had a radar, telescopes, all kind of stuff on this plane. There's your service payload. The avionics package was quite big, a lot of power. Now this kind of super pressure balloon is made out of a thicker fabric, and it's got a ballonette inside the balloon. So the ballonette would actually have the helium in it, and they could pump air in and out of this, and so they would keep the same shape to the outer balloon, and they would pump air in and out as needed to have ballast, essentially, to maintain the altitude they're operating at. So this is kind of what the, you know, this whole package fit on a pallet, basically, like, you know, you service with a forklift. Anyway, so much for the Chinese spy balloon. I'm more worried about EMP platforms. So it wouldn't take much to throw this kind of EMP pattern out on the United States. Focus in on Cheyenne Mountain, NORAD, our missile fields, the Western Coast facilities, Gulf Coast, East Coast, and maybe a good part of our industrial base and population center here in the East. You know, this would devastate just the coastal attacks alone. Just these 6 coastal rings would devastate the United States. Throw in 3 more here in the center of the country with some kind of penetration device like a glide vehicle, a raccoon, and you could really totally devastate this country with a balloon attack. But yeah, this is hang on. This is the ADIZ, the Air Defense Identification Zones around the United States. This little, it gets almost 400 miles here off LA. But if you get this balloon going up, if you start launching one of these balloons, let me explain this. If 400 miles, that balloon would be 80,000, over 80,000 feet in altitude before, yeah, the Earth is curvature. Before you, even if you had the perfect sensor that could sense it at 400 miles out, you probably don't. Most radars like that are only effective for maybe 250 miles. And a plastic balloon, especially if it's flying a stealth package, would be very hard to detect. But it'd already be practically beyond the range of a fighter with missiles by the time you saw it from the get-go. Not to mention, you got to get out to it. By the time you get out to it, it'd be at full launch altitude and maybe heading your way in one of those fast streams of air. So good luck having a countermeasure on this balloon that's going to a higher altitude than the spy balloon. The spy balloons flew where the aircraft were at. We're talking about stuff that would go higher than that. They're cheaper than those zero pressure, those super pressure balloons, by the way. The zero pressure balloons are cheaper. They're easier to operate. They just don't stay up for months. But if you're doing an EMP attack, you don't need something to stay up for months. You're ready to go. Your mission time is going to be 2 or 3 hours at most before you detonate it. So I'm showing you, so here's a mission I was doing 23 years ago. I just showed you what I was doing 25 years ago. All these were done on a shoestring budget from a small operation working out of a couple of garages here in Huntsville, Alabama. And I headed these projects up. That's why I know something about this. This is my friend Bill Brown here. This is our HARC Cat's Prize rocket. And what I'm going to show you is this little piece right here that goes from the bottom of this pink foam to about the bottom of here. Is I'm using that right now. One of those is my computer stand from my laptop. I'll show you that motor at the end of this video. There it is. From here to here, this black piece. I'm going to show you this piece. This whole thing is 17.5 foot tall. This whole package weighs over 300 pounds. This is on the aft deck the Mr. Offshore utility boat. You don't need a ginormous cargo ship to do this. This is a utility boat. It's not even the size of a supply boat. This is a boat. There's lots of them. They work the oil platforms and different tasks. Utility boats are a dime a dozen. You can rent them on the spot market, guys. I've leased these boats on the spot market to go out and do these kind of launches from. So yes, it's easily done on a shoestring budget. This whole project here, this is twice the weight that you would need for an EMP platform. An EMP device could weigh half this, and I'm going to show you the design of an EMP device that you can do this with in this presentation. That's the part that was a sticking point for our EMP commission on me showing this publicly, but we determined that there's nothing in here the Chinese don't already know. So who needs to know this is you. This needs to get to our decision makers in Congress. And that's why I am doing this. So we've already got this thing out to Senator Rob Johnson, the executive summary of my paper. I got a 24-page paper this is based on. So, and it's got to Congressman Mark Green, and there's a new bill released to Congress to deal with SUVs that has been prompted by this executive summary, my friends. All right, there it is going up. Now this balloon will expand 100-fold when it gets to full altitude. We launched this off of a small boat, guys. Small boat. You could launch the biggest balloons in the world that can carry your 4 tons off of a cargo ship easier than you can launch them from ground. Easily done, cheaply done. We had to develop our own avionics, guys, because we didn't have all the stuff you got in cell phones. We had 4 different ways to get altitude, and we also had a system we defeated GPS COCOM requirements, which were supposed to keep us from being able to do this. Supposed to block out position and rate of a vehicle that high. We figured out how to beat it, but we were using four ground stations, only 3 to perform that task. So here we are, guys, with our launcher avionics. We had switches in here so that the motor would not detonate until this Bella switch expanded at altitude and made full contact with the bridge, and it was altitude set. They're very settable. We had a vacuum chamber for doing that in, and we had these radios that we had all this tied in, and we actually had a code. You could only launch this by using the code. It was all encrypted, and we had a code. This is our ground stations. We built 4 of these. So we built 4 of those. We rented a boat, bought the balloon, bought the helium, bought the rocket, developed our avionics, did rocket motor test stand firing, and went out and did this mission, all for $150,000. And this was paying my guys. The workers were paid, unlike the HAL 5 Halo project stuff, which was club projects. This was a project with paid labor, $150,000. Admittedly, it was, 23 years ago. But holy smoke, guys, that's like how many AIM? You'd have to one AIM missile could buy me 4 of these missions. I could do 4 of these for a price of an AIM 9. So, guys, it's crazy. At least 3 of them, maybe 2 with today's prices, but definitely this is cheaper than the AIM 9 missile it would take to take it down. I could do a bunch of these. Not to mention a lot of this infrastructure would be covered through multiple launches, multiple vehicles. Here we are working out of one of the garages for our Halo SL2 mission, actually. And that's me trying to coordinate getting resources for make it all come together. Yeah. And that's Gene Young in his garage. We did also have 2 garages. We built avionics in one and rocket parts in the other. 2 garages, guys, in Huntsville, Alabama. And that rocket I showed you on the last one on the deck of Mr. Offshore was had a design set point to reach 100 kilometers. That circle. 3 of them would totally cover the United States of America. Just 3 raccoons, almost totally, with a few nips and tucks sticking out. Well, that's what your regular balloon ones are good for, right? At 100 kilometers, we'll launch this from the Gulf, launch one from the East Coast, one from the West Coast. Yeah, I was actually able to reaching, I was 200 miles off the shore of the United States when I did this launch. I could have reached Havana, Cuba with my rocket. In fact, that was part of our calculations. This shows a fill strength at the 480 kilometers burst at distance. And this is the purple line here. So it's 30 to 50%, even out here at the coastal areas. And you get 200,000 volts per meter, and our hardening standard is 85,000. And I've seen a guy doing tests with his own homemade EMP generator, defeating military hardened facilities that were hardened for voltages higher than what he was putting out. So I don't know if I trust the facilities hardening standards. So here we are. Here's one of our glide vehicles. That's my friend Tim Pickens, who later started Ryan Propulsion after he worked with me on HARC. This is our balloon launch return vehicle. This is a remote controlled aerial rocket vehicle for launching from a balloon. And we had an RF link to be able to control these things. It's got the ailerons, evolons. It's got a pitot tube. It's got a camera up here. It's got sensors, avionics bay. This is a rocket motor. It's lit up in the backside. This is the solid fuel grain. That's the nitrous oxide. We pioneered the development of hybrid rockets launched at altitude, which later spun into Spaceship 1, Spaceship 2. Tim Pickens and Steve Mistakes all worked on Spaceship 1 and Spaceship 2, some for Tim, and also another guy in our crew, Glenn May, who died. I think there's a picture of Glenn May in here. He died in the Mojave Desert at the cold flow test explosion of Spaceship 2 motor. All right, guys, here it is at sea off of another boat. This is a C. Michael Calais, our balloon launch return vehicle. This is a cold gas reaction control system, avionics, and also the launcher box here. And this is a launch rail. This box would turn and point it along the azimuth that we wanted to through a cold gas reaction control. And here we are, launching off the deck, kind of like launching a butterfly. We don't need a ginormous crane moving with the wind, a lot of stuff that's highly dangerous. That is me right there. That little tuft of hair. Yeah, short hair those days was me. That's Glenn May. He's the guy who died in Mojave Desert. That's Steve Mistakis. This is Mike Smith, the chief engineer of Aerostar, the maker of these balloons, the biggest balloons in the United States, including the balloons that are as big as an Astrodome. They can take the 4 tons to 120,000 feet. This guy is the chief engineer at that company that does this. That is probably Gene Young. That would be Gene Hornbuckle. No, that's me. That's Gene Hornbuckle. I don't know who that is. I think that's Chase Renager. Anyway, that was some of my team. Here it is, going up. This is what you can launch from a balloon. This can get cross range. You could do a lot. This was done as a phase 1 SBR for $70,000. Yeah, that's the paper study. This is how I do paper studies, my friends. This is how I do paper studies. Back in the day, the phase 1 SBR was $70,000, and this is what we did. Not only that, we actually did several rocket motor test down firings to characterize that motor. I actually had a subcontract to Lockheed Martin, who did the aero analysis to optimize the shape of this aero lift body. Yeah. So, and I bought the balloon, paid for the ship for $70,000. And we did ground launches. We built a subscale vehicle. We did ground launches with a subscale vehicle. That's not the same vehicle as the one hanging from a balloon. $70,000. That's how I do paper studies. Guys, once they get done launching balloons from the ship, they can launch rockets from the ship because this is an Israeli launch, but the Chinese have also developed these cargo containers that have rockets in them. In fact, the Chinese have developed a cargo container that's 2 40-footers welded together to give you 80-foot long rocket that can launch to orbit from a container ship. You can launch any kind of EMP weapon from a container ship, balloons, and then rockets if you so choose. So, and the Chinese know it. They developed the systems, and there's some video out there I've shown in a previous video once upon a time on Green Greg showing them depicting launching these from rail, from trucks, and from ships. So the Chinese they're already on top of this stuff, guys. Now here's a combination strike. Dr. Peter Vincent Pry taught us that if we were to be hit by an EMP, it'd be a multi-pronged attack. It would start with a hacking, and then there would also be people on the ground doing kinetic attacks on your substations. And we have reason to believe that that might be in play because it seems that there's sleeper cells. Iran is admitted to having sleeper cells in the United States for that purpose, to take out 20 of our substations. And we have indications that China is probably doing the same thing. Not only that, but China has components in a lot of our key grid infrastructure that could possibly shut it down electronically. So they don't have to just hack into the system. They're already there. So this is a combination strike showing a few bursts at balloon altitude, showing a few rockoons, like my Cat's Prize rockoon with 4-ton payload. I actually designed a rocket that would launch to orbit from a balloon. And we were playing around with a 8-ton payload system to double that. I could launch 100 pounds to orbit with a rockoon. I come up with a design for that and was pushing a business plan for that. And Iridium kind of killed the market for a while and backed out. But guys, this is what you could do from orbit. This could be done from a balloon too, or it could come in from a ICBM or a satellite going over. The Koreans are flying satellites that could possibly do an attack like this. So this is a combination strike EMP approach. This would totally devastate our grid beyond any belief. Nothing is hardened well enough to take a hit like this. And you could expect multiple hits of all these sizes, and especially this red circle. You could expect a lot of hits along these lines if we're under attack. If the decision's been made to put us under an EMP attack. Now, Russia considers an EMP event not to be a nuclear attack because the nuclear is going so high above the country, you don't feel the nuclear aspects itself. All you get is the electromagnetic piece of it. So they consider it electronic warfare. The Chinese may do the same, electronic warfare. Imagine that. So the threshold of doing an EMP may be a lot lower. So look, guys, I decided to go in here and say, well, let me take a brute force approach to coming up with a system that you could launch from a balloon that would defeat a lot of the countermeasures a lot of people claim would stop a balloon attack. Easily done. And I took one of the bigger launch vehicle warheads. I took the W-87. I could have chose a warhead from a cruise missile or something like that, which are smaller, more compact. This is at W87 next to person to give you an idea of scale. This could easily fit in a balloon package. So my whole proposition here is to put it in a barrel, a plastic barrel. And you don't even need all the structure in that warhead you saw, because a lot of this has got to do with spin control. You're not going to be spinning. You don't need all this. You don't need the outer casing. You don't need re-entry surfaces, because you're not going to be coming through the atmosphere in a re-entry. All you need is the actual warhead device, the fusion, and these things here. Just a subsection of this. So it actually turns out to be pretty small, but I still drew it like it's a W87. Now, a lot of people say, oh, great, well, we will detect radiation, so we'll see this thing before it comes. One thing, this thing's going to be, probably 200 to 300 miles from you and 20 miles up in the sky before it detonates, so you're not going to detect anything. But all that aside, if you had a detector flying pretty darn close to it, which I don't know how you're going to get there at the altitude to be at, but let's say you did, and if they put this thing in a bucket of sand, this is what 18 inches of earth would do. But rammed earth with sand actually has a higher density than rammed earth. Go look it up. That's in my paper. So this shows how much radiation, how much gamma rays get stopped by your round earth. And out of 32 rays, one gets through. So that's going to look pretty normal. You're not going to detect it. Then you get inverse square law. The radiation falls off to the inverse square of the distance, which means at 20 miles up, you ain't going to detect it. Even if you're flying 20,000 feet under, you're not going to detect it. You're not going to know it from a spy balloon. So here it is. Here is the W87 put in a bucket of sand, plastic barrel, or it could even be still. I chose plastic because I think it have a little bit less radar reflectivity, and you want to wrap some rope around it so it can support all the weight of your sand. But that can be done. You could wrap rope, or you can carbon fiber wind it like I did this motor casing sitting next to me to give it extra strength. And the sand could double its ballast. If you need a little altitude, you open the valve and let some of it out. I'm also going to show you where I have a cut down mechanism, which is drop the whole barrel of sand and just leave your warhead exposed. You don't want any on that sand when you detonate, because you don't want to block gamma rays. An EMP wants to maximize the gamma rays. So the sand could be released as a ballast to increase the altitude, which would likely be done prior to detonation, of course. Either it'd be released or you drop the bucket. I'd say drop the whole bucket or barrel. There's your bucket drop talked about here. Now, I took this to look more like the Chinese spy balloon. I'll be honest, though. This is if you want to be able to communicate to it. I'd probably have all this battery power and not have solar rays and all this truss, because that makes it easier to detect you. And you don't need it. There's nothing on here that's very high powered. Now, if you want to fly from across from China, in a super pressure balloon, yeah, this is what you do. If you're launching from a ship off the coast, you do not need any of this. Everything can be battery powered. As a matter of fact, it could be simpler than that. You could have this whole thing set where the device that's hanging beneath this is actuated by a wind-up timer. So if you hit this thing with an EMP trying to stop it, that wind-up timer will just keep click, 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 click. And when it hits the thing, it's going to send out a pulse of voltage that's going to maybe initiate the cutters to cut down the package, and suddenly the balloon jerks up, or if it falls down, in either case, you can have an accelerometer as the initiator for the nuke device to go boom for the EMP. That's simple. Nothing much needed. And so, yeah, that is going to be rather scary. So you could EMP this thing. It's going to be out of missile range. All right. Now, if you wanted to put electronics on it to command a signal to set it off, real simple. You could use a Raspberry Pi phased array to pinpoint the RF source position where you're going for. You could have a Iridium satellite modem on it. So this Iridium satellite modems, or anybody can use them. So approximate weight of the Iridium satellite motor is 5 pounds. Your spectrum surveillance module would be 5 pounds. This is militarized, Your solar panels, 10 pounds. You don't need big solar panels. If you have solar panels, just don't need to, not running. You may have a phased array antenna, but it's not a phased array radar, okay? So, but you can get rid of all this weight with a wind-up initiator if you're launching from a ship close to shore. So, but I'm keeping this bigger, grandiose design here just for the purposes of talking. I mean, remind again, a ship from short, you ain't got none of this. No truss, no solar arrays. You got maybe this. You might have a communication antenna to communicate with, maybe not. You might use some kind of AND gate logic. So you could have conditional logic for maybe you don't want it to launch prematurely or go off prematurely. You might have a signal going to it that says don't blow up as long as you get the signal from ground heading to it. And they just set it off, they could discontinue the signal. And that has other advantages to do something like that, or the other way. It's all AND gates, not gates, and such to do that. Here's your cutters to cut down this device. Here's your valve down here with a control line to it. These wires are for power and control. And this is maybe a potential detonator line, although you could just put a shaft in here to hold this thing and just drop the bucket and let her go. In fact, there may not be any avionics here at all. It's just a line of timer. You have an accelerometer in here, and that's all you got. Maybe something to, wind up timer to control the cut downs. This is notional, not the scale, but this is what the whole thing, all the components would be. So now you could reduce the radar reflectivity by painting your object, the package, with a polyurethane foam mixed with carbon black and some iron oxide. And I'm not going to go through the ratios on that. That would be classified, but this kind of information is available on the internet, guys. So this is how a poor man, without having the sophisticated radar absorptive materials that a nation state like China already has, can make a balloon payload more radar invisible. So you will know what radar you're working against on the frequencies and things like that. But hey, China has their radar absorbing material. Now, if you want to save more weight, you could actually these backpack nuclear devices would put out a heck of an EMP from 30 kilometers. And the smaller devices often are better because you got less shielding on them, which means better production of gamma rays. The shielding to protect the handlers from the nuke device inside are gamma ray inhibitors. So your smaller nukes, something particularly in the order of like 300 kilotons, is ideal. That's about what you would have with the W87. I say we shouldn't waste another AIM-9 shooting down one of these picosats, though. So what I've shown you here, guys, is that it is possible to design a package to fit under a balloon that would be hard to detect on radar. It's going to be launched far enough out that's going to be, when it gets within radar range to 200, 250 miles, then you've already got maybe up to 300 miles of range into the shore with your EMP, which will take out most everything of interest. So by the time they could actually see you, you're already on them. You're up at the altitude, and at that altitude, an AIM-9 has a published range of 20 miles, but that's shooting out, not up. Shooting up, it would do good to hit 10,000 feet higher than it's launched from, because the burn time on the AIM-9 motor is only about 5.4 to 6 seconds, depending on the design of the motor. So the AIM-9 is not good for shooting up, because it's basically a projectile, like a bullet shot. And a bullet shot up is not going to reach over 10,000 feet either. So if you got that 20 millimeter cannon on board and you think you're going to take that balloon out, you're not going to reach it. And if you did reach it, it poked a bunch of holes in it. It's just like, this thing is so, these balloons are so big, it's like opening doors on a warehouse. I took that phrase from Canadian Prepper. So you're not bringing it down. But I know this to be fact because I knocked some holes in a balloon I launched from the old airport at Huntsville and carried an oxidizer package for in situ testing. And it still launched with some holes ripped in it. And it went, now that thing only reached about maybe 40, 50,000 feet. But it had holes in from the get-go. If you're already at altitude, it's going to take a long time to come down with some holes punched in you. So, and then you may float at a lower altitude quite easily for a long time. So we had holes in a balloon and we launched it and flew it. So imagine that. So this whole idea that easy to take down, and you're not going to reach it. Once it gets 120,000, 100,000, 80,000 feet, you'll be hard pressed to take a balloon down to 80,000 feet. So, but we need to pay attention to which kind of balloons we want to take down. I'll talk about what we need to do to take them down in this presentation. But yeah, stratospheric balloons are important in our scientific community. They're used a lot by major science organizations, NOAA, universities, corporations, other nations, NASA, There's a lot of National Science Foundation, a lot of scientific enterprises out there flying balloons to do atmospheric research for telescopes and things like that. Yeah, you can fly major, large telescope platforms from balloons. They handle lots of satellite. It's cheaper. So let's see. So you can get, and we're talking about our 50 pounds avionics. So, you know, the total thing here, but your balloon and your helium also factor into the weight. So we could say that if we did a 50-pound system, the whole flight train would be about 150 pounds. This would be a lot smaller than the rockets I was launching from balloons, guys. So it takes a cubic foot of helium at sea level to lift 1.1 ounces of weight. So 150 pounds would require a balloon at sea level of 2,640 cubic feet, but you got to expand that because the atmosphere drops off, because at 53,000 feet, about where the Chinese balloon was, you're going to be 10 times bigger, and you're going to be another 10 times bigger if you're going to 100,000 feet and above. So just to show you what all that means is if you do the volume ratios, do the calculations, the minimum radius that should even be targeted at 50,000 feet would be, this is radius, mind you, 18.47 foot. So really and truly, you shouldn't mess with a balloon that's under 40 foot at, say, less than 60,000 feet. At 100,000 feet, it's going to be bigger. So that would be about an 80-foot balloon. So here you are. At 50 to 60,000 feet, where the Chinese balloon flew over, anything that you would target should be at least as big as a bus, 40 foot in diameter, or two buses if it's 98,000, which is roughly your 30-kilometer altitude, or above, 80 feet in diameter, at least. At least. Some of those balloons they shot at were not any size at all. One in Alaska was said to be about the size of a car. That's not a balloon, it's a direct threat. So I wouldn't target it. Plus, there's a lot of databases you can check to figure out what kind of balloons are out there. That legitimate balloons file notice to airmen when they fly. Airports fly balloons. But hey, the first weapon balloons were actually flown by China. Well, I say first weapons balloons. In modern times, they had to go for the Fugo balloons. There were balloons used for reconnaissances about far back as the war between the states. And there were some other attempts to have fire balloons, like back in the wars of Venice and some of the European wars. But in any event, the Fugo balloon actually caused some people to no longer be with us. It took out a wife and her kid, a woman and her kids, a mother and her kids. But these were intended to cause fires on the West Coast. This is a picture of one reinflated that they brought back and flown over California in January 1945. Now, you can also release biological systems from balloons. This is a package from dropping submunitions, and here's the total package, what it looks like here, of the E-77 bomb munition system. These things were designed to be able to drop rust disease, to be able to take out wheat rust, to take out crops as biological weapons. They also developed this little glider. Now, this glider opens up, and it's got a little shuttle clock, kind of like the Spaceship One, Spaceship Two design. That would open up and feather out to kind of control its descent. And this little glider, you can see it's about maybe a foot across in each direction. That's, I guess, about scale there, 6 inches. So it's a little over a foot across in each direction here. It's a small glider. This is developed in the 40s. Very primitive system here. The E-77 balloon bomb gyro control glider munition. Now they had a gyro on it. So now the Chinese today have gotten much more sophisticated. This is their drones that they developed from a PC board. You can see they got little Evelons out here and a little servo motor to actuate the Evelons. This whole thing's 32 centimeters wide. You can see this thing's very small package, but you could put little bomblets on it, biological warfare systems, or just do intel reconnaissance from this. But the thing is, as a bio delivery system, and by taking this package straight to the target, they could do some damage with it. And also as balloon, I've talked a lot about swarms, drone swarms in warfare, and how they can be so effective in warfare and scary. That's what they're talking about. And these are pictures of them dropping them from balloons right here. Balloon swarms. They're talking about dropping a whole lot of these from a balloon. This looks like one of those super pressure balloons. They're showing it communicate with satellites. So there you go, my friends. There's some end notes here. So let me end the presentation. We'll stop the share. All right, bottom line is that China could, or any nation, including this, could be done by terrorist groups, guys. If they could get a hold of a EMP device, they could actually do something like this. And there's thought to be some on the black market. So this is a serious thing. How do you counter it? See, these things can be at over 80,000 feet by the time it even pops up over the horizon. Over 80,000 feet. You're already almost out of range of any fighter aircraft with a missile. Yeah, we've got some Aegis missiles, but if they fire a bunch of these, will the Aegis missiles be right here sitting offshore? And will they launch so many balloons that you basically overcome the Aegis capability? We use them all up. Now, they could just be launching decoys at first. I mean, they could launch 100 of these balloons. China has so many cargo ships, they could launch so many of these balloons, and most of them could be decoys. What do you shoot at? What's real? What's not? How do we deal with this? This is a threat we've never seen before. Because one, you're going to have a hard time detecting it. If they launch it in daytime, in the middle of the day, or if they launch it at nighttime, you're not going to see it visually. If they launch it in the morning or evening, you'll either see the sun reflecting off of it or being refracted through it. It'll shine like a star. You'll see a bright little star on the horizon. That'll be your balloon. In the middle of the day, they're very hard to see. These zero pressure balloons are almost transparent, which means they're not going to reflect as much radar. A super pressure balloon was not transparent. It's more radar reflecting. Mylar balloons reflect a lot of radar. But you usually have to get in about 250 miles where the radar, really 250 miles where the radar starts to pick you up. They're going to go, what is this? And they're going to scratch their head a little bit before they even come to the conclusion, well, maybe it's something to worry about. So how long does it take to get from what's this to a plane getting in the air? And this thing's going to be sitting at 120,000 feet. What are you going to do? You're too late. Everybody says, Greg, hit it with a laser. When you're coming up at 20 miles high and you're miles down range, no laser. Yeah, we got all these great lasers. Are good in short theater ranges, but across those distances, you get beam spread. The beam's going to spread out so much, it's not going to be effective. Now, if you can put a laser up close to it and put a hot spot on that package, then maybe if you could get a missile up to it, it could hit that package where the hot spot is. Like an AIM-9, it's got a heat seeker. But if that package ain't hot, it's not going to want to seek for it. It'd probably go for the balloon above and just poke a hole through it and open the barn doors, and it'll just keep going. So unless it explodes inside, in which the overpressure. See, the thing about zero pressure balloon, they got pressure release vents. So it would take quite an overpressure to really pop the whole thing. You might could do it, maybe, but just putting a bunch of holes in it don't guarantee you're going to cause the whole balloon to pop, like the Chinese super pressure balloon, which definitely popped one yet. This is a different kind of a balloon. It's not nowhere near as easy to take down. So don't let what you saw the Chinese balloon give you any thought for what to do here. One, you won't reach it with an AIM-9. Two, if you could, it probably ain't going to bring it down, and it probably wouldn't detonate when you hit it. It'd probably just go straight through it. Because that polyethylene is like 3 mil stick. It's very thin polyethylene. Maybe not even that. It's very, very, very thin. It's thinner than a sandwich bag. A sandwich bag is thick compared to the thin these balloons. Because you don't want to have some load tape. So if you hit a load tape, you might detonate it. But they're very, very thin. You just go right through it with a rocket if you're not careful. So yeah, you got to be careful of these things. They're tough. They're hard to bring down. There has been cases where these things have been floating low enough for fighter aircraft to shoot at them in the past. I mean, balloons were flying low for some reason, and they were shooting them with 20mm cannons and just keep on floating. So what do? There's two things needed. Early detection is going to be key. We need to see, to get these things, we need to know they're being launched before they get to launch altitude. We need a system of detectors offshore, whether it be airborne, like some of these long-range, loiter, high-altitude aircraft, or from ships. We need something out toward the edge, or at least most of the way out toward the edge of our ADIZ, maybe something halfway in between. They can detect this stuff a lot faster before it gets to 80 kilometers, before it gets to over 50,000 feet. We need to get something there to it before it gets over 50,000 feet, if at all possible. High altitude platforms might also be able to deliver a laser if properly designed. Like if you can get a high altitude platform to loiter at a very high altitude. And if you could shoot a laser straight up, and if it's got the right kind of dither mirror, so you're penetrating less atmosphere if you're going straight up rather than going crosswise. And then if you had a dither mirror at 100,000 feet, the atmosphere is only 1/10, no, excuse me, only 1% of what you can grab. You could actually get some range without as much beam spreading. The beam will spread even in a vacuum, but it's not as much. The atmosphere will cause it to spread a lot more. I mean, we like to think of lasers as being coherent. It's what we like about them, but they do spread over distance. Look it up. The calculations can probably be found on the internet. Beams will spread. So at distance, you know, your laser is just not posing a threat to the system. Another way might be to launch something. Build some cheap rockets. I know sudden missions have been outlawed, but don't call them sudden missions. Call them like little miniature rockets or something, like brilliant pebbles. Put a whole bunch of them in a package that you launch from maybe a balloon or a solid rocket booster. I've talked about that kind of defense. How this is something you launch up, and it may have like little drones in there, or some smaller missiles that would carry a chain with a hook on it. So the missile goes through, the hook grabs, and between you rip a really big hole in the balloon. But what you really want to go, you need to find some way to go straight for that package. Because if that package, it's anywhere near shore, if it gets within 400 miles of shore, you're at risk. Yeah, if you're 120,000 foot, you're already at risk. If it gets what you saw, look at the figures I gave, you're already at risk. You need to take that thing down fast before it gets to altitude. Because if they just got a wind-up timer on it and they're trying to hit it with electromagnetics, it's not going to affect it. And if the whole thing's accelerometer initiated, when you shoot the balloon down, it's just going to detonate. It'll detonate. Wherever it is, boom, it'll probably release the sand and detonate. That's probably exactly what will happen. And in that case, game over, guys, game over. All right, I promised y'all a treat. I showed y'all that motor. I'm going to show you. Indeed, I use it as my laptop table. And here it is. This is the HARC, Cat's Prize, Cheap Access to Space Prize, solid rocket motor fuel grain. This is that tiny little piece of the rocket. All the rest of it's oxidizer. This one's been burned. We test fired this one. This is part of our test fire series. So I told you we dialed out for 150,000. This test, burning this motor and a few other burn motor tests was part of that. We did a 3-second burn on this, just as a test burn, to characterize the performance of this fuel grain. The fuel in this is hydroxyl terminated polybutadiene. It's the same fuel you find in solid rocket motors that the Army and all the military uses, except it does not have the ammonium perchlorate, the oxidizer mixed in, so it's not explosive. This is a carbon fiber wound casing. This is a high-tech casing here with hydroxyl terminated polybutadiene motor. It's a synthetic rubber. Actually, asphalt performs better. I find it hard to believe. Cheap old asphalt does better than that as a hybrid rocket motor. So, and I've poured asphalt motors too. We tried a lot of different fuel grains. We've done a lot of experiments over the years. And you saw some of the missions, the photographs from them. This is too easily done, my friends. Too easily done. It'll be done cheap. You can fly several of these for the price of an AIM-9, especially with Chinese labor. So, my friends, don't discount the balloon. The balloon is an asymmetrical weapon. That's exactly the kind China would like to use. Remember Sun Tzu? Don't do what the enemy expects. Do the opposite. Nobody's looking for this. The intel says that the Chinese have an entire balloon force, just like their rocket force. And you got that many people with these kind of technologies. We've already seen that they're planning to get to 30 kilometers. We've already seen that they got these military glide vehicles as drop vehicles. They've already thought about all of this. And yeah, there's plenty of literature out there about launching from sea. So the Chinese have got all this covered. I've not done anything, showed you anything that they don't know already. What I'm doing is trying to dispel a lot of misconceptions that are in our public today. A lot of misconceptions. A lot of people are saying, well, this can't be done. The payloads would be too heavy. The balloons would be too big. You wouldn't need a balloon as big as my Halo balloons, or as big as, especially as big as my HARC Cat's Prize balloon. I can do it from a smaller package than that. And I did this stuff 25 years ago. That's what I was doing. So if 25 years ago, if I'd had a device that would go boom, which I don't want one. I won't have one. Don't try to give me one. You'll be in trouble. But if I had that, I could have taken out a major part of our grid. If I had a few of them and some ships and some budget, and could have stationed them off all the shores, I could personally have taken down this country. I will not do that. It's against my very fiber. And the only reason I'm bringing this up is to show you how easily it is done. I'm bringing this up as a warning call, a clarion call to wake people up to be able to stop this kind of thing. I've chaired 2 power grid defense conferences. I don't want this to happen. That's why I'm here. That's why I'm taking it to you. Show this video, share it wide. Public needs to know, because the public needs to know that we have a threat here. You need to be prepared for the grid to go down. There's many things that can take our grid down. You need to be prepared for the grid to go down as a member of the public. But furthermore, share this with people you know in the military and intelligence and government communities. Share it with your congressman. Go to my Freedom Restoration Foundation website, look on the freedomrestorationfoundation.org and look on the Action Center page and scroll to the bottom, and it'll show you how to find your congressmen and your senators. Share this with them. Freedom Restoration Foundation.org. It'll be in the show notes below. All of that, I'm going to say thank you for watching, and stay true to who you are and what you believe, and try to keep this country free. So I'm glad you watched this far. Tell me in the comments. Let's keep this country free and keep the lights on. May your lights burn long. Well, that I'm going to say, Greg out.